पास होगा तो मोस्ट प्रोबेबली भी बन जाना चाहिए।
Right, guys. So we'll start in 5 minutes. Let's just wait everyone to join.
भाई यार मेरा यार पूरी आदत नहीं है भाई, पूरा मैं अपने लैपटॉप और कैसे वापस से मम्मी ने क्या बोला कि नॉर्मली हाँ मैंने भी देखी थी अभी कल, क्या कौन है लेकिन ये लोग देख क्या रहा है हमें। पहली ही गलत है, इज नॉट ऐसे।
All right, guys. So welcome to the XR session for Road to DevSoc Beyond Reality. We will be exploring the definitions and use cases of XR technologies, and we also have an AR tech demonstration lined up at the end of the session. So make sure to stick around for that. So I'm Achintya Gupta. I'm an XR developer at CodeChef-VIT. I started off in XR using web-based XR, but now I'm also experienced in AR dev using Unity and Spark here.
I'm Wahaj Mustafa. I'm also an XR dev at CodeChef-VIT. I started my journey with Unity and I started from game dev and got into XR, and I still do XR in Unity.
All right, so starting off with the session. So these are the topics that we will be discussing in today's session. We'll start off with augmented reality, then move on to virtual reality, and finally end with a demonstration using Spark here. All right. So moving on. So what is AR? AR, of course, stands for augmented reality. Now, AR is a technology that combines the real world with the virtual elements and allows the user to interact with these computer-generated elements through their device and make it seem like they're interacting with the real-world objects in their immediate environment. It basically overlays digital content into the real world, often through the use of a smartphone, tablet, or a number of wearable devices. AR technology uses a number of sensors, cameras, and displays to integrate digital information like images, videos, or of course 3D models into the physical world and enables the user to interact with these digital elements. So moving on to types of AR. Now, there isn't really a universal way of classifying AR. However, almost all AR applications can be classified into the following categories: marker-based AR, markerless AR, and projection-based AR. So, marker-based AR. Marker-based AR is a type of AR that relies on specific markers or visual cues to trigger the AR effect. These markers are patterns or images designed to be recognized by the AR systems and allows the system to usually just anchor content like a 3D model to the marker itself. Next, we have markerless AR. As you can probably tell from the name, this type of AR does not require specific markers to trigger the AR effect, hence the name markerless. Instead, this system relies on computer vision, sensors, and algorithms to track the real world, and align virtual objects in the physical environment. Markerless AR provides flexibility and freedom since you don't need a specific fixed marker. However, it's much more complex and computationally intensive. Finally, we have projection-based AR. This type of AR uses projection mapping techniques to project or overlay images or videos over a real-world object. Just think of it like a projector, right? So it relies on projecting. So okay, now it relies on projecting light and visuals onto a real-world surface and create an interactive experience in an interactive AR experience. Okay, so let's discuss some AR technologies and frameworks. First, of course, we have WebXR technologies. So WebXR or web-based XR aims to implement XR experiences through the web. This is still a relatively new field within the field of XR and is often more limited than traditional XR. However, it does have really great potential. Some popular frameworks for the WebXR include 3JS, A-Frame, ARJS, Babylon.js, and 8th Wall. So you can see the logos of the same here. This is the logo for A-Frame. Next, we have the logo for AR.js. Then we have the logo for 3JS, 8th Wall, and Babylon.js. After that, we have two AR filter tools, which are, of course, used to make all those Instagram and Snapchat filters we all know about. We mainly have two softwares under this category: Spark Studio for Spark AR, which is made by Meta, and Lens Studio for Snap AR, which is made by Snapchat. Spark AR is of course used to make Instagram filters, and Snap AR is used to make Snapchat filters. Next, we have the game engines. So these are the tools that people often know about when they think of XR development or AR development. The most popular ones are of course the Unity engine and the Unreal engine. So Unity's AR foundation is essentially a cross-platform framework that simplifies AR development by providing APIs for AR functionality across both iOS and Android devices. It allows developers to build AR applications that can run on multiple devices. This, along with Unity's asset store, which contains a wide range of AR assets such as AR templates, marker libraries, 3D models, and scripts, makes Unity a go-to for AR development. Of course, Unreal Engine also provides built-in support for AR Core and AR Kit, which are the SDKs for Android and Apple respectively, which allows developers to create AR applications that can take advantage of platform-specific AR capabilities. Finally, we have the aforementioned native AR SDKs for the development of AR. The one for Apple devices or iOS devices is called ARKit, and the same for Android devices is called AR Core. Both support a wide range of devices with a multitude of features such as image tracking, face tracking, or plane tracking. And the list of supported devices is also increasing day by day. It's not very large right now. However, it will get there. Okay, so now I'd like to talk about some applications for AR. Of course, with the immersive and interactive experiences AR can provide, it has found a wide variety of use in in the gaming and entertainment industries. Right, Pokemon Go is the example that I'm sure comes to everyone's mind when it comes to an AR game. AR also helps with product visualization in retail. You can, for an example, you can think of IKEA's AR app, where the AR app basically allows you to take furniture and place it into your house using AR. So you can just view it in your house and just see if it fits really well or not. Right now, another major application of AR is in the medical industry. So, for example, doctors these days are actually now using AR to visually demonstrate medical conditions and treatment options to patients. This, of course, gives doctors a great deal of training and confidence, and of course, also gives the patients some confidence in the doctors itself to just make sure they know what they're doing since they understand the process. Now, the final application I want to touch upon is the use of AR in the education sector. Obviously, since AR comes with a lot of visualization benefits, students do find it easier to study and understand concepts using AR, right? I actually made an education-based web AR project using A-Frame and AR.js for a hackathon called EdLens. In this project, we used OCR to identify a word written on a piece of paper, right? And then we displayed a 3D model for the same word using web AR inside the browser itself. So again, as I mentioned, this sort of application can be used as an educational tool, right, to help students understand concepts. Similarly, we also have a multitude of other applications for AR in tourism, architecture, communication, and the communication industries. And obviously, the applications for AR are extremely vast, and I can't possibly cover them in one session, but I hope you guys get the idea, right? All right, so let's talk a bit about VR now, shall we? So VR basically creates a simulated immersive experience completely detached from the real world. So that's where the key difference between AR and VR comes up. In AR, you try to simulate the digital experience and integrate it with the real world, right? You see the digital assets in the real world. However, in VR, the world is completely different. It's a completely abstract world. Now, VR typically involves the user wearing a head-mounted display, or what it is commonly called a VR headset. There are many motion tracking sensors attached to these VR headsets, which simulate the movement of your head in the virtual world. So you can look around inside the world in a 360-degree vision, right? Um, so, and along with the VR headset, often controllers are also included in the VR setup, which is used to which uses their own motion sensors to simulate hand gestures and a sense of physical movement. VR also incorporates immersive audio, so that is spatially positioned to help enhance the sense of being present in a virtual environment. All right, so again, let's talk about some development tools for VR, right? So again, as you can see, we have the two popular game engines that we saw previously in the AR development tools, Unity engine and the Unreal engine. So both Unity and Unreal have pretty extensive documentation and active developer communities dedicated to VR development. These communities provide a lot of resources and a lot of doubt clearing for you to proceed and become an active developer. They also provide a wide range of tools and features and flexibility for creating immersive VR experience, whether it's for gaming, training simulations, or some other VR applications. Now, the choice between Unity and Unreal often depends on the specific requirements for the project, development, team preferences, and the familiarity with the engines. That's what it depends on, right? After that, of course, we have the VR software development kits or the VR SDKs. So the three I would like to talk about are OpenVR, the Oculus SDK, and Google VR SDK. So first off, OpenVR. So it is a VR SDK developed by the Corporation. You might recognize Valve as the creator of Steam, which obviously is a platform for games, right? It provides APIs that allows developers to create VR applications which are compatible with a wide range of VR devices. OpenVR is also the underlying SDK for the Steam VR platform, which provides additional tools, features, and APIs specifically for VR development on Steam. So for Steam games, for example. Next, we have the Oculus SDK. It is developed by Oculus VR, which is now a subsidiary of Meta. It provides tools and APIs for building VR applications specifically for Oculus devices. So you might have heard of the Oculus headsets like the Oculus Rift, Oculus Quest, and the Oculus Go, right? So that's what you use the Oculus SDK for. And then finally, we have Google's VR SDK. It's simply named Google VR. It was formerly known as Google Cardboard, though, which you guys might have heard about. It basically just enables developers to create VR applications for Android and iOS devices, which you can then put into Google's own Cardboard and use and just view the VR experience through that, right? All right. So now let's talk a bit about the applications of VR. As you can probably notice, they're not that different from the applications of AR itself. Of course, we again have the gaming and the entertainment industry. I'm sure everyone has heard of popular VR games such as Beat Saber and Half-Life Alyx, right? So after that, there is also the education industry. Of course, the use of VR in the education industry is not as widespread as AR yet due to the requirement of a large VR headset. However, it is still a very useful tool for the same when it's available. Uh, Let me give you an example. So VR can provide realistic and engaging simulations for for scientific experiments and phenomena, helping students understand what really goes on behind the scenes of science, I suppose, right? Um, Now, VR also has a wide range of applications in the healthcare industry, offering solutions, therapy, and pain management, and more. VR is often used in rehabilitation programs. It's used to assist patients from in recovering from injuries and neurological conditions. You can probably just go on YouTube and search up VR therapy, and you'll see someone learning how to walk again while wearing a VR headset. Um, Okay, so I also want to talk about the metaverse here. I'm sure you've all heard of the metaverse given how much hype it has garnered over the last 2 to 3 years. The term metaverse often refers to a virtual space where users can interact with each other and digital objects in real time. It aims to create a seamless and immersive virtual space where users can explore, create, communicate, and collaborate with, with other people. Currently, a fully realized metaverse has not been created. However, efforts are being made by various companies and developers to build elements of the metaverse in the VR space. So these include social VR platforms such as VR Chat and AltSpace VR, as well as major initiatives by tech companies such as Meta's Horizon Workrooms and Microsoft's Mesh. Obviously, the metaverse holds tremendous potential to has holds tremendous potential to revolutionize how we interact, collaborate, and experience these virtual worlds, right? All right, so I guess that's it for the theory part. It's not much. So now we have that live AR demonstration lined up for this session, as I mentioned previously. The AR demonstration itself is meant to help you to familiarize yourself with AR development using the aforementioned Spark AR platform. We will give you a brief introduction of the Spark AR platform, and then we will move on to the demonstration itself.
Okay, so I hope everyone can see my screen. Okay, so this right here is Spark AR, and so as you can see, um, we have a few options here. So option to create a project, and you can video call it, or you can create a template. So there's one specific template that we're gonna use today, and that right here will be the face decoration. So Just wait for this to load. Okay, so this is loading in right here. Um, just give me a second of this. Okay, so as you can see here, this is the viewport. So this is where all the objects in your scene will be. So the scene has a camera which simulates your phone cam. This right here is a face tracker object. The glasses you can see here are this object. It's called delete me because they expect us to replace it basically. This right here is a sample video. So you can change the video right here. You can select another person, or I could just turn on this camera and uh, just wait a second. All right, I'll just restart this bit. It can sometimes get a bit glitchy. Okay, so now it's loading again. Let's see. I'll restart SparkAI itself. Just give me a second. Okay, so let's try this again. So this is loading again. Okay. Hmm. Okay, let's try another scene then. Let's go with the, let's say, the head decoration. Hmm. Okay, so let's go back to one of these videos. All right, so it's working again, thankfully. So as you can see here, this is the hat that's being simulated here. You can change to any other person, and this is a full body view. All right, so you can actually change the object that's being displayed here. So let's just press this to pause. So just a brief overview. This is the workspace button. So it shows you different parts of the workspace. This again allows you to change the video. This allows you to play and pause. This allows you to go to the next frame. This allows you to stop. This is restart, and this is search. So what we're going to do right now is we're going to add an asset here. So an asset is something like, let's say, your textures or your 3D models. So you click the plus button and you can search the AR library. So right here, let's go for a simple 3D shape. So 3D objects, 3D shape. So let's take a cube and let's import it. Okay, so this should be imported now. So as you can see, we can find it in the assets view. Okay, so now what we do is we delete this cap object and then we can drag in the cube. So as you can see, the cube is right here. We might need to drag this a bit, and let's try hitting play. So as you can see, it's tracking the cube now. So whatever you put under here, it's gonna map it to the face. So I'll explain what's in the scene. So this is the face tracker object, as I mentioned, which is used for tracking the face, and that has a drag here component. That's a null object. So it's sort of used to group objects. And this is the cube that is attached to it. And this is the occluder. So if we go back here, so if you look closely, um, you can see that the mesh kind of goes through her head. So that is done by the head occluder. So if that wasn't there, then uh, I could show you. So it does not look as smooth. Like it doesn't look properly 3D. So let me just undo that. Okay, so again, let's delete this, add a cube. So I'll have to import that again. So 3D objects, 3D shapes, and a cube. So let's drag that over here. So now, let me just put this a bit here. So you might have been wondering what this thing is. So this is the patch editor. So this is where we code in all the logic. So it's a visual scripting. So you don't have to type any code over here. If you want to code, you can use JavaScript, but that's a separate thing. So what these nodes are doing is like, um, so for example, this finds a face, this selects one, then it adds the position um, to the cube. So we won't be messing with that right now. So um, what we're going to do is we're going to create a gesture node. So this is for those gestures or interactions. So let's add a screen pinch. So this gets triggered whenever you pinch the screen. So let's go to the cube, and you can actually add a node from the cube onto here. So if you click the arrow next to the position, it appears as a node over here. And um, what we want to get is the scale. So um, let's click the scale. Let's drag this in. So this over here does not work because these are the wrong data types. So the expected type was vector3 and we gave it a scalar. So now instead we're going to add in a pack. So what we can do is we can take the scale from the pinch and we can input it into all three of the dimensions, and then we can apply it to the cube. And as you can see, the screen is white, but if you just rotate this, it'll fix it. Let's just reset. Let's, yeah, let's just keep this here. Okay, so now if we hold play and then we go here and simulate touch, if I hold Alt, it'll simulate a pinch. So as you can see, as I pinch the screen, okay, you can see it better now. So the cube expands and grows bigger. So this is just one of the few interactions that you can add. So if you go here, you can add for the cube, you can add something when you tap the cube, or in the face tracker, there's gestures for even like lowering your eyebrows, nodding your head, rotating your head, etc. So that's all for the demonstration. So that was an overview of how to use Spark AR. So this is something that's very simple to use. You could download it today or tomorrow, get started, and it's a great way of getting into AR. Okay, guys, so now we'll be taking your questions. Okay, Akshat, the name of the software is Meta Spark Studio. So you can see this here. So you can download it from Meta's website. Um, it's completely free and you can get started. Will Spark AR come with all the asset or should we get it from somewhere? Okay, so in Spark AR, it there's a default library and you can also um, download assets from outside as well. So there's a website called Sketchfab, and right, so there are websites like Sketchfab or Polygon where you can download any 3D model or you can make your own. Let's say if you use Blender or 3ds Max. So anyone else has questions? You can ask about Spark AR, you can ask about AR or VR or MR in general.
Any resource recommendation for beginners? All right, so for Spark at least, Spark actually has a quote unquote beginner course, which is actually just free to use, right? If you just, I'll try to send the link here in the chat, but if you just go on Google and just search Spark Learn, you'll get an entire course of Spark, right? So let me just try to get the link sent here.
And for Unity also has a lot of um, free tutorials on the web. Unity also has its own Learn website. So on Unity's website itself, you could find some courses, but there's plenty of tutorials online for Unity.
Any communities. So of course you can go on to like the Spark forums or the Unity forums, right? But from my experience, the best way to interact with other XR developers is just go on Discord and join a Discord server. So for I'll give you an example, right? So when I was learning WebXR, WebXR's documentations unfortunately aren't that comprehensive or they're too confusing, right? So instead of trying to refer to the documentation, I went on Discord and joined the Discord server for A-Frame or the Discord server for ARJS, right? And the people over there are really helpful. So I would recommend trying out Discord servers.
Okay, how to start with AR, VR from where? Okay, so this entirely depends on what kind of AR, VR you want to do. So if you use Unity, so like let's say you want to make any games, then I would suggest using a game engine. If you're making an app, you can directly use AR Core for Android or AR Kit for iOS. Those are the SDKs. And for WebAR, Achintya.
Right. So for web AR, honestly, again, I would just recommend trying to go to the documentation. Right, the starting part of the documentations is actually pretty simple. So I would recommend a framework such as A-Frame. So A-Frame itself basically integrates AR functions into HTML. Right. So if you're someone who is maybe experienced with front end development, that's somewhere you can go. Or if you're experienced with backend development, like I was, right? I started off with AR.js. So again, the documentations, to be entirely honest, weren't that helpful. But if you do go on those Discord servers I talked about, you will find help. And of course, you can refer to projects that are already uploaded on GitHub if you want, for reference.
Okay, is there a way to convert VR to 3D game and vice versa? So a lot of the times, let's say you take Unity and you make a game, it's not that difficult to make turn that into VR. It's just a couple of extra functionalities, and vice versa. Yeah, you could do that as well. So for game development, it's actually very straightforward. Okay, what type of AR should I start off with as a beginner? So I would say just start off with Spark AR because it like lets you do things instantly without much code. So you can get a feel of it and like have fun for a little bit, and then you can choose what kind of AR you want to do. Like Achitya, would you like to add on?
Yeah, I mean, I completely agree because something like SparkAR is actually a pretty simple platform to get into, but of course, the skill ceiling, you could call it, is pretty high on the platform, right? I think it's a similar case with Unity as well, honestly. You can make simple AR experiences like just placing a cube into the room pretty easily. And for this kind of stuff, there are many tutorials available on YouTube. However, again, if you want to make really complex applications, you can do that as well with Unity. Of course, one thing I would also recommend is, like, for example, if you're starting off with Unity, right? A lot of the times when you want to implement some quote unquote custom functions, which are not there as a template in Unity itself, you'll need to do what is called custom scripting. So for Unity, the custom scripting language is C sharp. For SparkAI, the custom scripting language is JS. It's JavaScript. So again, that's what I would say. You just start. So as for where you should start off, I guess you just start trying to make like all different types of ad. Make a simple marker based AR application, make a simple markerless application, and then just try to combine the two, or maybe like start like, suppose for example, I'll give you an example. If you look at IKEA's AR application, right? You could after starting off with there, you can try implementing that. You get what I'm saying? So it's just you take it in steps, and eventually you'll be able to do a lot. All right, guys. So I guess we'll end the session here. So thanks for coming, everyone. And if you guys have any doubts, if you guys any doubts regarding how to get into AR or VR, you can reach out to either of us. And yeah, that's about it.
Yeah, thank you guys for attending.
All right, thank you guys.